The next topic we are going to be discussing is continuous compounding formula, looking at our financial advisor problem. Now this is dealing with interest that is compounding continuously. It's just continually being compounded. So just to recap, I have $7,500 in savings that I'm looking to invest into a U.S. savings bond for my son's college fund. He will be attending college in 15 years. My goal is to save $20,000, and I'm looking for the financial advisor who can make me the most money. Currently, the annual percentage rate for a U.S. savings bond is 6%. What we need to determine is what is the future value of my money after 15 years. Now, we need to use the continuous compounding formula. Now, the continuous compounding formula is the future value equals the present value multiplied by E. E is a symbol that stands for a number. If we look here in the calculator, you can come up with E by going second ln. And then that will give you E raised to the, if we want to figure out what E is, let's raise it to the first power and press enter. And E is the same thing as 2.718281828. And this number keeps on going on forever. So that is what E equals. So going back to the continuous compounding formula, it equals F equals P multiplied by E, which stands for a number, raised to the R, which is the rate multiplied by the T. We're going to go ahead and define our terms. P equals $7,500. The rate is the APR of 6% written in the form of a decimal, which is 0.06, and for 15 years, so T equals 15. We're going to input these values into our formula. We're trying to figure out the future value, so we're going to leave that F. P is equal to $7,500 multiplied by E raised to the rate of 0.06 multiplied by T 15. So order of operations states that what we need to do first is the parentheses, we need to do the exponent. So we need to determine what 0.06 multiplied by 15 is. I'm just going to rewrite this. F equals $7,500 multiplied by E. And when we figure this out, 0.06 times 15 actually ends up being 0.9. At this point, we can determine the future value by just inputting this into our calculator. So I'm going to clear out my screen and go 7,500. And then I need to get this E. And this E is found by going second ln. And the little E pops up with the little caret saying, okay, go ahead and enter the exponent now. Well, the exponent is 0.9, so I'm going to go 0.9. I'm going to close my parenthesis and then hit enter. And so that tells me that the future value of my money is $18,447.02. Now, this is still not my goal of $20,000. So what I need to see is I need to determine, well, how much money do I need to invest in order to achieve my goal using the continuous compounding formula. So, how much do I need to invest if my goal is to save $20,000 in 15 years with an APR of 6%? So we're going to write the continuous compounding formula here. F equals P multiplied by E raised to the R times T. My future value is $20,000. That's my goal. I'm trying to figure out, well, how much more I need to invest from $7,500. $7,500 is not achieving my goal, so I'm going to have to I'm going to have to invest more, so I got to figure out what that is. The rate is 6% in the form of a decimal, which is R 0.06, and then the time is 15 years, so T equals 15. So let's just go ahead and input this into the formula. 20,000 equals P, that's what we're trying to determine, E raised to the R, which is 0.06, times T, which is 15 years. Okay, order of operations says I have to do the parentheses, this exponent bit first. So I'm going to rewrite the problem. 20,000 equals P multiplied by E, and 0.06 times 15 is 0.9. Now, at this point, we're at a crossroads again. I can do this problem two different ways. So I'm going to solve it one way, and then I'm going to show you how you could solve it another way. So I'm just going to rewrite this over here. 20,000 equals P E raised to the power 0.9. Okay, so back to the first way. The first way is I just need to figure out what I'm trying to isolate P, get P by itself, but there's this number around it. I need to figure out what E raised to the 0.9 is. So I'm going to clear out my calculator. I'm going to go second ln, so I can get that little E caret, E raised to the 0.9, close the parenthesis and hit enter, and I have a big old decimal again. So I am going to write that down. 20,000 equals P, and E raised to the 0.9 is the same thing as that big old decimal, and I need to write out that entire decimal. 2.459603111. Now this big old decimal is multiplied by P, so in order to isolate P, I need to do the inverse operation of multiplication, which would be division. So I'm going to divide this big number by itself. And whatever I do to this side of the equation, I have to do the same thing to this side of the equation. So I'm going to divide 20,000 by 2.459603111. Now 2.459603111 divided by 2.459603111 is actually equal to 1, and 1 times P is equal to P. So now we have P isolated. The only other thing I need to determine is what is 20,000 divided by 2.459603111. And that's easy to do. You just do the division, and it actually ends up being $8,131.40. That is what my principal, the present value of my money needs to be that I need to invest in order to achieve my goal of $20,000 using the continuous compounding formula with an APR of 6% for 15 years. But I want to talk about, I'm going to go back up to here, I'm kind of rewind, go back up to here, 20,000 equals P multiplied by E to the 0.9 power, to talk about a different way to solve this problem to get the same exact answers without having to write out all these decimals. So what we need to understand first is that E raised to the 0.9 is the same thing as this number. So instead of writing this whole number out, what I'm going to do is I'm just going to leave it as E to the 0.9 power and recognize this is a number. This is a number that's multiplied by P. So in order to isolate P by itself, I need to do the inverse operation of multiplication, which would be division. And I'm going to divide it by whatever this number is. And this number is E raised to the 0.9 power. And that's the E. This is what E to the 0.9 power is. And whatever I do to this side of the equation, I have to do to the other side. E raised to the 0.9 power. Now E to the 0.9 power divided by itself, E to the 0.9 power, that's going to end up being 1. 1 times P is P. I have now isolated P. P is by itself. Now I just need to determine, well, what is 20,000 divided by E to the 0.9 power? And to figure that out, I just need to put it in my calculator. So I'm going to go 20,000, 1, 2, 3, divided by E, I need to get E, so I need to go second ln, and see it gives me that little caret, and now I just need to put 0.9, close the parenthesis, and hit enter. And if you see, I get the same exact answer that I did over here. So that ends up being $8,131 and 39 cents. I guess I forgot to round. It's the same thing. I think this is supposed to be 39 cents as well. I just I didn't round it correctly. So that is our principle. Just a different way of solving it. So there you go. Oh, I wanted to analyze the whole. We have been using this financial advisor problem to using a whole bunch of formulas. So now I want to kind of analyze the whole thing. We've been talking about you are now all my financial advisors who are competing for my business. Let's just go ahead and analyze all the results. So we had the same, we are investing $7,500. We are investing it at an APR of 6% for 15 years. When we use the simple interest formula, the future value on the money was $14,250. That was not my goal of $20,000. So I need to invest more money. When we put $20,000 in for the future value and we solve for P, what we ended up with was $10,526.32. That really meant that I needed to invest an additional $3,000 for my principal in order to achieve my goal of $20,000. Now let's look at the same numbers, but all we do is change the compounding formula to annual compounding formula, where the interest is compounded once a year. Well, the future value on our money raises quite significantly to $17,974.19 in 15 years. Now, this is quite a jump from the simple interest formula to the annual compounding formula by just changing the formula. That's, quite a significant jump. And when it still wasn't enough though. So when we put 20,000 in for our future value and we solve for P, we ended up determining that I need to invest $8,345.30, which is additional, $800 from the $7,500 that I have, $845.30 additionally that I need to invest. We switched up the formula to compound and monthly formula. And what we found is that even though the interest is compounding and additionally 12 more times throughout the year, I still gained about $400. It's not as significant of a jump from simple interest to annual compounding formula, but it still was a jump. And the jump here for when the amount I need to invest was about $600, $649.66 that I need to additionally invest into my $7,500 to achieve my goal. We looked at the compound and weekly formula, and you know what? From going from the monthly formula of n equaling 12, the interest compounding 12 times a year, to the interest compounding 52 times a year, it's only a jump of maybe $32, which is interesting. And if you see here, the amount that I need to invest would be $635.61. So it's not that much. I mean, that's only it's not dropping that much. And when we look to compounded daily formula, that's daily. That's my money is being compounded, the interest, 365 times in a year. And notice from compounded weekly to compounded daily, that's only a jump of a couple dollars. And the same is true. The initial money that I need to invest is $632 more than the $7,500, which isn't that much of a difference from the weekly, even though I'm compounding my interest, a lot more times. And then we go to compounded continuously formula, where I'm continuously compounding at every second, millisecond, and what I see is that it looks like there's only a $2 difference between compounded daily and compounded continuously, and it just looks like maybe a 60-cent difference for the principal. So the principal that I need to invest is $631.40 additionally to my $7,500, which is only a 60-cent difference between the compounded daily formula and the compounded continuously formula. So what this tells us is that the interest, when you compound it, the interest reaches a limit. The interest when you compound it, just doesn't keep going skyrocketing off forever. It actually approaches a limit and of the amount of money that you can obtain when you keep compounding the interest over and over.